All right, so we have been doing, this is the assignments from Friday, April the 10th, and we've been spending a little bit of time more recently on slope. In a nutshell, your final is going to cover three topics: algebra, moving things from one side to the other, slope, and intercept, and we need to talk about intercept today. So the assignment that I thought really encapsulated everything that you've learned so far about slope was this one, graph from a slope-intercept equation, and we're going to be doing similar things with the word problems. Okay, so I'm going to show you the abstract version that is just moving the points around to just a completely abstract equation. But what if you were actually trying to solve a word problem? So the abstract version of this is if it just gives you an equation with x's and y's. In this case, the intercept was 8, so the line started on the y-axis at 8. And then the slope was negative, so it goes down like this one does. It goes down 4 and sideways 3. So this goes from 8 down 4 to 4 and then sideways 3 to 3. So I have here a line that starts at 8, 8, and then it goes down 4 and sideways 3. And so that's the graph that gives me that line. And this was called slope-intercept form because there were two things. The slope that told me how fast the line went up or down. In other words, this would be a steep, high slope, and then this would be a not steep, small slope. So, and then there's this number here, which is where it starts. So you could either start high on the y-axis with a lot, or you could start low on the y-axis. Like if you started off owing money, it might be down here. Right, and by manipulating those two quantities, the intercept and the slope, you can change things about the graph. Now, what if you are trying to do word problems that are like that? So we're going to find two quantities here. We're going to find the intercept and we're going to find the slope, and then we're going to use that to graph. Just like we did here when it was just totally abstract, we have to identify the slope and the intercept and then use that to graph. So let's read this word problem. I need to pause. And I'm going to need to snip every time because I want to go back and actually be able to manipulate this. So I'm going to have to pause every time. It says Omojobi is 220 centimeters tall. So let's draw a picture. Here is this guy, and he is 220 centimeters. He wanted to fill up his pool so that it would reach this height. Okay, so he's filling up his pool, and here's his pool, and he's going to fill that up with water. It says the water level rose by 6 centimeters each minute. Okay, so the water level, let me do blue because that'll be better. Maybe a highlighter blue. The water is rising at a level of 6 centimeters each minute. And then the word each here, I'm looking, let me give my keywords for how I can tell what I'm looking at when I look at my key numbers. If I see the words each, every, or per, or rate, or ratio, those are all indications that I am looking at the slope, m, the slope m that goes in this spot here. Okay, so in a word problem, the way to tell what goes in this spot here, the thing that tells me that I go down 4 and sideways 3, the slope, the key words to look for are each, every, or per, rate, ratio, those kinds of things, speed. So the thing that tells you how fast the line goes down. And in this case, each minute says that this thing here, the word each says that this thing here is the slope. So I know in this problem the slope is 6. And in fact that it's positive 6 because the water level rose. All right, you need to be really careful that the level is going up. All right, so let's continue. And reach the desired height after 20 minutes. This is actually telling us a coordinate. It's really kind of tricky. It reached the desired height. Well, what height did it reach? It reached a height of 220 when the time was 20 minutes. All right, so that gives me a coordinate. So I know where the dot should start. So again, going back to just the purely abstract, the way to graph a line is you put your first dot where it starts, where the point that you know, like for example here we know that the y-intercept is 8, so I can put my first point there. And then the second point, I use the slope to go down 4 and sideways 3, and now I've got my line. All right, so I needed those two things, and that's what the word problem has given me. It's given me the slope. I know that the slope is 6, and it's given me a coordinate. In this case, it hasn't given me an intercept. It's really kind of tricky. So it didn't give me where it started. It gave me a coordinate, 220 for height and 20 for time. All right, let's see how this plays out in the problem. Okay, so I know one of the coordinates was after 20 minutes, the height was 220 in heights. So looking at this, I've got height going up and down, so that's water level in centimeters, and then time going this way. So my first points after 20 minutes, I know that after 20 minutes the water level was 220. Okay, and I know that the slope was positive, so it looks something like this. And now I need to get this slope to work out to be, for the slope to be 6. And this again is tricky. So the slope needs to be 6, but if I look at my graph, I can only move my dot in intervals of, let's see, 100, 110, 120. So every time I move this dot, it goes up by 10. So I can't go up by 6. I can only go 10 or 20 or 30 or 40 or 50 or 60. So we need to figure out some kind of a multiple of 6 that goes into 10. So the easy way to do 30. Yeah, 30 would do it. So if you went 5 minutes, then that would be 6 times 5 would be 30 centimeters. Or the one that I was thinking would be 6 times 10 would be 60 centimeters. All right, so I'm going to move, let's move 5. So I'm going to move 5 minutes, and after 5 minutes it's going to go 30 centimeters. And that's because the slope is 6. So really pretty tricky. So again, 5 minutes. Okay, so between 5 and 20, that's the 5 minutes. It's going to go down by 30. So I was at 220, and it's going to go down 30 from there to 190. Okay, so let's check my slope triangle. What is the rise between 190 and 220? So y2 minus y1. Let me snip this so I can examine. You have to know. You could go, good point, you could go up and sideways. So it could be that the second point you went up 30 and sideways 5. That would also work.
And that would be the same slope because right through the whole, a little triangle, a big triangle. Is there a difference between the slope on the same line? If you have one line, how many different slopes do you have?
Right. Right.
You just have one slope.
They're all the same, yeah. So I wanted to prove to you that this thing does in fact have a slope of 6. It went from 190 up to 220, and you remember y2 minus y1, right? So what is 220 minus 190? So this is y2 and this is y1. So what is the rise? y2 minus y1. What's 220 minus 190? 30, which is what I wanted because this is x1 and this is x2, and the difference between those, I believe in time it was, I can't remember, 5 and 10, or it could be 10 and 15. So in that case it would be x2, which is 10, minus x1, which was 5. So how many minutes was that between here and here? To go from 5 minutes to 10 minutes was how long? Alvaro, from 5 to 10, x2 minus x1, 10 minus 5 is 5. And then what is 30 over 5? 30 divided by 5 is 6, which is what I wanted. All right, so I constructed this correctly. I have a graph that had a point at 20 minutes and 220 centimeters, and then the slope was correctly 6. But I had to find a correct multiplier to get that to work. So clearly we need lots of practice. I plan on doing maybe 5 of these. So there's probably going to be a second video to go along with this. All right, so hopefully I got this right. It'd be very embarrassing. Okay, good. All right, Carl and his truck. So I hope that you don't get frustrated with this. It is actually, as a teacher perspective, people ask me all the time, what is math good for? And this is the kind of thing that math is good for, like the practical thing. So it just so happens that the practical thing that it's good for is actually, quite a bit harder because the world is messy. Here we go. I'm looking for the words each, every, or per, and then I'm also looking for a known coordinate. So where I'm going to start the graph, and every per is going to give me the slope. Carl filled up the tank of his truck with 400 liters of fuel, and he set out to deliver a shipment of bananas to Alaska. The truck consumed... Okay, so I have to draw a picture of Carl and his bananas. Okay. Okay, here he goes to Alaska. Okay, so the truck is consuming 0.8 liters of fuel. Oh, my keyword each, for each kilometer. Okay, so that tells me my slope. My slope is going to be 0.8. And the most likely thing is I'm going to want to multiply that times 10 so that I can get it to be 8. But we'll see. And then he filled up his truck with 400 liters of fuel. So that means he starts with 400 liters. So the coordinates here, the variables here, are going to be the liters of fuel that he has left in his truck for the distance that he's traveled. So he starts life, this one is easy because it did give you the intercept. He starts off life with 400 liters of fuel, and then we need to figure out what the slope is going to work out at. So again, the coordinate that he starts off on with 0 miles, he has 400 liters. Liters? A liter is a little less than half a gallon. And this would be 0 miles. So the coordinate gave us was in fact B, the y-intercept. So this was a happy one. It gave us where it started. And now I need to figure out for the slope. Let's see. So let's try it by 100, because clearly I can move this guy, this little dot. Every time I move it by 50. But it would be more convenient to multiply 0.8 by 100. So let's multiply 0.8 by 100 and see how far down I have to go down here. So after 100 kilometers, if he's losing fuel at this rate, then it's 100 times 0.8. And my decimal is all messed up there. 100 times 0.8. And then somebody in here who remembers from scientific notation what this is automatically. I move the decimal point 2 times. What do I get? Somebody.
What's 0.8 of $1?
Whoops, I need to pause. Okay, so this was, in fact, 80, and so that's how much fuel he's lost. Okay, so after 100 miles, he's going to use up 80 of the 400 liters that he starts with. And that's going to give me my slope to be negative the way I wanted it to be. So where would I put this that has him lose 80? It's going to go down 80. I want to go down 80 after he's driven, Juan, you were saying 320? Okay, so let's see how that works out from a slope viewpoint. All right, so I just wanted to prove to you that the line that we drew did in fact start with 400 liters of fuel that he set out to deliver his bananas, and it does in fact have a slope of 0.8. So to do that, I'm going to draw a slope triangle from here to here. And the slope is from the slope intercept, or from the slope formula, it's y2 minus y1. So that's 400. That's y2 minus y1 is 320. Over, and then x2 minus x1. Well, that's x2 is here at 100. And x1, it started at 0. So that's 100 minus 0. So 400 minus 320 is 80 over 100 minus 0 is 100. And if I move the decimal point 2 times, I do get a slope of 0.8. Okay, so the slope that I have drawn has a slope triangle where the slope is 0.8, in fact negative 0.8, and the intercept is 400, B is 400, just like I wanted. And I just wanted to remind you again just how easy this is. It's just that we have a word problem. Right? We're figuring out two things. Where does the line start? It starts at 8. And then from the slope, negative 4/3, how far down does it go and how far sideways? It's just that we're dealing with real numbers now. Like we're dealing with numbers like 400 and 300 and 200 and so on. So that's the only difference, is that this is a little bit more realistic. All right, so I'm going to record another video for the next 3 examples.